questions over the homework assignments? Any questions over any of the assignments thus far? So what we're looking at today is continuing on with what we did yesterday, again, simplifying these radicals into a simplified form. And when you know that a radical is going to be in simplest form, if no radicands have perfect nth powers as factors other than 1, talking about we can't have 2 to the 4 halves, we can't leave it like this here because we can reduce. We also can't have the cubed root of 8 left over because we could actually take the cubed root of 8. Cubed root of 8 is 2. We can't have any radicands contained in fractions, and no radicals can appear in the denominator of fraction. This is what we wrote down yesterday. And again, this still applies to what we're talking about today. Now, the first main property that we have is the product property and our quotient property with these radicals. The product property is telling us that the nth root of a times b can be rewritten as the nth root of a times the nth root of b. We can split it apart, but we can also go the other direction and put it back together. In our,
how do you get numbers out of letters? Like, there's no numbers in that.
Well, a number, a letter has
yeah. We. So. So. For these here, guys, we're letting a and b any real number. So any possible number, this holds true. So we're just using the letters to hold the place of any real number that we could plug in for those spots. But in this here, we can take 2 cubed roots, as long as the indexes are the same, and actually multiply the numbers inside of them together, which actually works out to be the cubed root of 8, which is 2. And we can do the same thing with division. And we do this and combine them together only if the two numbers are divisible or divide evenly. Otherwise, we'll have to do something a little bit different. Now, the first one we're looking at is this here, a, the cubed root of 12 times the cubed root of 18. Now, we're not able to simplify the cubed root of 12 or the cubed root of 18 individually. It doesn't come out to be a whole number. But what we can do is actually multiply these together. Because of our product property, we can rewrite this as the cubed root of 12 times 18. And at this point here, we just need to multiply 12 and 18 and see what we get. As we multiply these together, we should get 216. Now we can try taking the cubed root and plugging this into the calculator, because if we do and it comes out to be a whole number, that's all the better. So it does work out to be 6. Now if it didn't work out to be 6, we would just need to do our factor tree. So breaking this down into the smallest prime factors. Guys. So for 216, we can do 2 and 108, which would be 2 and 54. 54 is, guys, 2 and 27. Well, 27 wouldn't involve 2 anymore, but it would be 3 and 9, and 9 is 3 and 3. Well, we have 3 3s and 3 2s. So really what we can say is that we have the cubed root, as long as it doesn't erase, of 2 cubed times 3 cubed. Well, the cubed root of 2 cubed is 2 times 3. Because 2 cubed is 8, but if we take the cubed root of 2 cubed, the cube root and the cube will simplify out and leaves us with 2 times 3, which is our 6. So this one here worked out to be a whole number. But if it didn't, we would have to use the factor tree to try to see and group our groups of 3 for cube group. Any questions on this here? Any questions on any of this here so far?
I'm just wondering when you're going to drop one of those.
It'll happen.
Dude, have you ever noticed how we threw some marker after every problem? He would drop one day.
I have. All right, guys. Let's look at the next one. All right, guys, let's focus in. So the next one we have is the 4th root of 80 over the 4th root of 5. Now, if we want to simplify this, we need to get the radicals out of the denominator. We can't have a radical in the bottom of a fraction. But one of this here, we can actually combine these two. And the reason we would want to is because if we look at the numerator of 80 and the denominator of 5, will those divide evenly? Well, yes, 80 will divide by 5 evenly. And since they'll divide by 5 evenly, we can rewrite it as one big radical of 80 divided by 5. And we'll only want to do this if, one, the indexes are the same and the numbers inside the radicals on top and bottom will divide evenly. Now 80 divided by 5 will be 16. And now we can see if we can take the 4th root of 16. And the 4th root of 16 is if we did a factor tree, if we can say 2 times 8, and 8 is going to give us 2 times 4, and 4 is 2 times 2, so we would have 4 times. So this 4th root of 16 is 2. Any questions on any of this here? Let's look at 2 more of these. So the next one that we have is the 3rd root of 4 times the 3rd root of 128, and we want to simplify this. So in some of these here, we could try plugging this into the calculator to see what we get. But if we use these properties, we could rewrite this as the 3rd root of 4 times 128, because we can simplify this to one radical. And we could do 4 times 128. And I believe it should give us 5/12. And we could try this in the calculator to see what we get if this does give us a nice radical. And it gives us 8. Because again, we could do the factor tree to see what we get, but luckily this one does give us a whole number. Any questions on any of this here? If there's no questions on A, we can go on and look at B. Now, we see this here, we do have a radical in the numerator and denominator. Will 192 divide by 6 evenly? So those will divide evenly, which means we could rewrite this as 192 over 6. And we do this because, again, those two will divide evenly. If they'll divide evenly, we'll go on and combine it to one radical and go on and simplify it. Because we can do 192 divided by 6, which gives us 32. And again, at this point here, we can see if we take can take the 5th root of 32. We can type that in. And we can, it gives us 2. So 32 is 2 to the 5th. And the 5th root of 2 to the 5th would just be 2. Any questions on any of this here? Okay. If we're good with both of these here, let's look at these next two here. Writing them in simplest form, simplest radical form, so we don't want a decimal on either one of these here. Now we can try plugging in the cubed root of 135. And would we get a whole number? Unfortunately, we won't. So really what that means is we'll just need to go back to a factor tree to see what cubes there are, if there are any, in 135. So what is one number we know is divisible? We'll divide into 135. 1 will work, but also 5. 5. Well, we know 5 would work because any number ending in 0 or 5 will be divisible by 5. So we can say 5 and 27. Now 27 is divisible by 3 because it'd be 3 times 9. And 9 is 3 and 3. So we do have 3 3s and 1 5. So really what that's telling us is that we could rewrite the cubed root of 135 as the cubed root of 3 cubed times 5. And as our properties we looked at today, we could really say that this is the cubed root of 3 cubed times the cubed root of 5, because we can break those two apart. Just like we did earlier, putting them together, where we can multiply two radicals together and merge them so that we're just multiplying the numbers inside. We can actually go the other way around and split them apart. And the reason we would do that is because, well, the cubed root of 3 cubed is just 3. But we can't simplify the cubed root of 5. So what we actually get is 3 times the cubed root of 5. And that's it. Questions on this here? Any questions on how we simplified the cubed root of 135? All right. If there's no questions on A, we can go on and look at B. B is the cubed root, or the 5th root of 7 over the 5th root of 8. Well, we do have the same index, and will 7 divide by 8 evenly? No. So we have to do a different method for simplifying these here. Now the 7 is a prime number. There's no way we can rewrite it as anything else or a number to an exponent. But we do need to look at 8. Is there any way we could rewrite 8 as a number to a power? Right? Well, if we look at the factor tree for 8, 8 is going to be 2 times 4, and 4 is 2 times 2. So we could rewrite 8 as 2 cubed. And we want to write it in this form so that we can simplify the radical in the most easiest way possible. So whenever we're looking at this here, and the numerators number inside the radical and the denominators number inside the radical won't divide evenly, we're going to have to do this here. We need to rewrite the denominators number, so here 8, in the simplest form possible. So 2 cubed, write it as a prime factorization, this prime numbers to whatever power. Because we want this radical in the bottom of the fraction to simplify out. Yes? Because instead of 2 to the third, what exponent would have been nice to have in the bottom of this fraction? Because what exponent would simplify with that fifth root? Huh? Because why did this one simplify out? Over here. Because the root and the radical were the same, yes? Because they're divisible here. Because a cubed root, any exponent that's divisible by 3 would make it simplify, yes? So for this one over here, we need the exponent to be what? 5, or some number that is divisible by 5. So 30 would work, but what is the next one after 3? What's the next number we would need after 3? It's 5, because if I had 2 to the 5th, well, the 5th root, because if I had the 5th root of 2 to the 5th, the exponent and root would cancel out, yes? Well, how many more 2's do I need to get this to go from 2 cubed to 2 to the 5th? 2, yes? So what we're going to do to simplify this is we're going to multiply the denominator by the 5th root of 2 squared. And we're also multiply the numerator by the 5th root of 2 squared. Because what we're trying to do is to increase the number of 2's that we have in the denominator so that its exponent and the root will simplify out. Because in the numerator, well, we're going to have the 5th root of 7 times 2 squared. In the denominator, we're going to have the 5th root of 2 cubed times 2 squared. Now in the numerator, 7's prime, yes? So the only factors for 7 are 1 and 7. There's nothing going to be in common. So we'll end up multiplying this all together. Well, we can say 2 squared is 4. Now in the denominator, we do have like bases, 2 and 2. And whenever we have like bases, we add the numerators. So 2 to the third times 2 squared would be 2 to the 5th. And that's what we wanted, because we're trying to get that exponent in the denominator to be 5 or some factor of 5. So 10, 15, 20, 25, 30. But we want it to be the smallest one possible. Because since we started out with 3 2's, we only needed 2 more to get to the first 5. And well, the 5th root of 2 to the 5th is 2. In the numerator at this point, we can just multiply 7 and 4 together and get 28. And that's it. That's all we have to do for this here. Now, we do need to make sure that the numerator doesn't have any 5th roots, but the only way that would work out is if we added some in if there weren't already some to begin with. But that's all we have to do on this here. Questions on this? Let's look at one more of these here with the division, because I feel like the square root, not the square root, the cubed root of 500 is something that y'all are more or less comfortable with. The division one, not so much. Now looking at B, we have the 4th root of 19 over the 4th root of 4. Well, 19's prime. There's nothing we can do with it, and 19 and 4 won't divide evenly. So since 19 and 4 won't divide evenly, we're not going to rewrite it as the 4th root of a fraction. We're not going to combine them because that really doesn't help. So what I'm looking for is to see if I can rewrite 4 as a number to a power. if it's possible to rewrite it as a number to a power. Because 4 is 2 squared. And that is helpful because that tells us that we do have 2 2's in that 4th root. And how many 2's do I need to get the 4th root to go away? I need 4. Because 2 to the 4th is if that denominator was the 4th root of 2 to the 4th, then the 4th root and that 4 would cancel. Yes? And we're always wanting to go up to the next multiple of 4. So if we'd have been at 6, because if we had started out at 2 to the 6, well, the next one would have not be 4, but it would be what? Next multiple of 4 after 6? 8, because we're just trying to go up. We can't go down, but we can go up. And for 4th roots, we're just looking for the next one that would make it simplify out. And here, well, how many more 2's do we need? 2. So we'd multiply top and bottom by 2 squared. And one of the ways that we know that we've gotten too many is if what we're multiplying, so here in green, if that exponent is greater than the index. So here, if this 2 that we plugged in we're doing is greater than 4, we've added too many. If we add too many, that means we're going to have to pull them back out later. And when we do this multiplication, well, the numerator is going to be the 4th root of 19 times, well, 2 squared. Because we have 2 squared. We don't just have 2, we have 2 times 2. Now, at this point, we could have multiplied it by our 2 squared. Or really, in the calculator, we can't really type in the 4th root of 19 times 2 squared because either calculator, the yellow or the graphing calculator, will actually turn it into a decimal. It's going to want to take the 4th root. But what we could do is take 19 times 2 squared in the calculator. It will do that for us. So it'll tell us what goes in the radical. So really, we're looking at 4 times 19, which would be 76. And the denominator would be 2. Because the 4th root of 2 to the 4th is 2. And on these here with these fractions, we're really trying to simplify that radical as easy as possible. Any questions on this here? Well, we can go back and look at A. Well, 500 does not have a perfect cube. But we can look at the factor tree. And well, we don't know that 5 will work. Does it be 5 and? Well, 5 will still work with 100. It'll be 5 and. And 20 is 5 and. 4 is. So we have 3 5s and 2 2's. So really we're saying the cubed root of 500 is the same as the cubed root of 5 cubed. Five cubed times 2 squared. 5 cubed times 2 squared. Well, we know what the cubed root of 5 cubed is. It would be 5. Because the cubed root of 5 cubed is 5. Because our 3 in the cube, cubed root and 3 would simplify out. Will the cubed root of 2 squared simplify? Well, no, we need 3 of them. We only got 2. So that would stay. And whenever we can't simplify something out, we can't pull the 2's out, we really don't leave it as 2 squared, because we do know what 2 squared it is. 4. So we can just leave it as 5 times the cubed root of 4, instead of leaving it as 2 squared where we have these powers and radicals all together. Any other questions on this here? Last part of today's lesson is rewriting these in simplest form, because again, we cannot have a radical in the denominator. So what we do for these here, 1 over 5 plus the square root of 3. You don't have to write it there. I'm writing it there because I have a feeling that this notebook slide is still having issues with scrolling. It's still going to want to scroll it all the way to the top or all the way to the bottom. So I'm going to write it over to the side. Now, we've done something similar to what we're going to do for this here. If you remember back to our complex conjugates, using those to simplify I out of the denominator, we're going to do a similar thing for this here. We're going to multiply top and bottom of this fraction by the denominator, except we're going to change the sign in the middle. So we're going to use the 5 plus the square root of 3, multiply it on top and bottom, but change the sign in the middle from positive to negative. Now the numerator of this is kind of nice. It says 5 minus the square root of 3 times 1. Well, anything times 1 stays the same, because we just get 5 minus square root of 3. Now in the denominator, we're going to have to distribute this out, as our 5 times 5 is 25. 5 times negative square root of 3 is negative 5 square root of 3. And then we'll do positive square root of 3 times 5, as long as I don't try to erase. It's going to be plus 5 square root of 3. Well, that kind of works out nicely. And lastly, square root of 3 times negative square root of 3 is negative square root of 3 squared, or we can say negative square root of 9. Either one of those would be the same thing. So this will let me scroll. Now the numerator is still 5 minus square root of 3. In the denominator, well, we don't have any like terms so far with 25. But our negative 5 square root of 3 plus 5 square root of 3 becomes what? 0. Whenever we add or whenever we subtract two of the same thing, they cancel out and become 0. Minus. Well, now we need to figure out what the square root of 3 squared is, and it would be 3. Square root of 3 squared. Well, I could rewrite the square root and say that we have 3 to the 1/2 squared. Powers and powers multiply, which just tells us we have 3 to the 2/2, which is just 3 to the 1st. So that's why that simplifies out. Or if we said the square root of 9, well, the square root of 9 is 3. Well, we do need to simplify the denominator. 25 minus 3 is. And 5 minus the square root of 3 over 22 would be the final answer. Questions on this here? Let's see here. We had 1 over 5 plus second square root 3, yes? Isn't that the exact same thing we got? Because negative 3 plus 5 over 22 is the same as 5 minus the square root of 3? Well, yeah. That is negative square root of 3 plus 5 over 22. These are the same, except they flip the square root of the number. Same exact thing. Well, if we looked at the next one, 1 over second square root of 7, I believe it's plus 2, minus 2. That's if it's plus, so 1 over second square root of 7 minus 2. We get square